So I want to give a quick demo of DuckDB and just kind of an application of how I use it for some of my personal stuff. The idea of DuckDB is the ability to process a lot of data that are kind of typically in flat files using SQL queries. And to see a little bit, give a better idea of how it's going to work, I'm just going to use it to analyze some of my banking data. The bank allows me to export my transaction as CSVs, so I'll use the CSV data. Let's take a quick look at what that looks like, where I have, what you would expect, some dates, an amount, account number, transaction details, and a balance. So for me, of course, since I'm interested in interested in the long-term behavior of my account, I'll be interested in date and balance information. And here's kind of the application itself is I have a bunch of DuckDB statements. So these are all part of SQL queries that I'm passing along to DuckDB, and it will give me useful details about, hey, how much amount do I still have to pay to the bank in terms, the my interest that I have to pay. So not the principal, but the amount, the extra amount. When will the principal be fully paid off? And as I have a offset account, when will the account be fully offsetted? So none of those numbers are the actual numbers that I have. None of those are the actual transaction. This is just sample data that I'm playing around with. So let's just take a look at how we'll be able to build such predictions using DuckDB. And I have here a whole bunch of transactions that I'll prepare, and I'll just zoom in a little bit just to make it a bit easier. And I won't need to look at the files elsewhere. Well, the only thing I want to point out for the files is I do have a bunch of different files around bunch of different dates, so different date ranges for the files. So I don't have a single file that I export. Just periodically, I'll just go and export some CSVs from the bank account, drop it in this folder, and then I can run the instructions on top of them. Okay, so the first thing is I'll just go over and read some files. So to do that, I'll just jump into DuckDB. So at the bottom of the screen, I'll have my DuckDB transactions, and on top of the screens, I'll have the queries that I'm running into it. So the first query is a very, very simple query. I'll just read all of the CSV files. So here I have my folders and I have all of my files. They all start with NAB, and then there's a date. So I'll just say a star. So just read all of those files and return to me what you have. And what do I have? I have a bunch of all of those statements. So these are the same statements that I had earlier, where I have the date, amount, and the balance statement. And okay, so what if I want to try to start understanding the data set that I have? The first thing I might want to know is, well, I have the account numbers. Well, how many accounts do I have? How many am I looking at? Okay, well, I have two accounts. I have, you can see the 1-1. Yep, so it's a big, large negative number. That's probably my loan. And the 22 account is my saving account. Okay, so I know some information about it, and now that I want to start analyzing it, I don't want all the columns. For example, I don't care about the day-to-day movements of it. I only care about, if I want to see, well, how long it's still going to be to zero, I'll just focus on the balance account. So I'll just simplify this, where I'm picking up the date, the balance, the account number, and where I'm reading it. I'm just limiting it to 4, just to have a manageable output inside of that. What I notice here, the first thing I notice is that when I called read CSV, DuckDB was able to parse out a little bit of the data that I have. I would notice that all of the accounts are integers. All of the balances are floats. But it was unable to pick up, the dates. These dates are actual dates. So what I'll do here is I'll grab, what I'm going to do in this query here, I'll grab again the same fields, but what I'll do is I'll change how I'm going to read the data from CSVs. Instead of, I'll pass in other arguments. So the first argument is, again, the wildcard, where all my CSVs, what am I interested in? And then the other field is, hey, I'm going to pass in the date format. Hey, if I have a date, how do I want you to interpret the date? And it's going to be, okay, well, if I look at it, it's a 1 or 2 digits for a date. there's a big table that tells me how do I parse them. So that's a %D. I have a dash. Then I have the month as a three little acronym, and then I have the year as a two-number date. And the data type that I want is type date. If I run this query, now I have dates, doubles, and accounts, but the date is now of a date format, which will make manipulations a little bit easier afterwards. Okay. And now I do know here on the first for transaction, I'm only looking at the account, the loan account, and I can focus on that by just using a where statement, and it will just give me this. And then I don't have, I'm only looking at my loans. I don't need to worry about that column anymore. Every number that shows up is definitely going to be a loan. Okay. So now what I want to do is, well, one model of using to predict how my account is going to go in the future is I can just do a linear regression. The first order linear regression. What is the line that best fits the data? And in many systems, when I have to do it, I have exactly the date that I want. I have a date, I have a number, do me a linear regression based on this date information. It'd be nice if it was simple as that. But unfortunately, if I look at the DuckDB documentation here, where I'll look at the function called regSlope, I'll notice that it wants a double-double. Okay, so I have to just convert my date to an integer of some kind, or a double of some kind, the number, and then I'll be able to do the transaction. Of course, the easiest way to do that is, hey, I'll just take the current date minus the date. What is that interaction going to be? Well, that's going to be the number of days ago that I have. Okay, so I have now days ago and the balance. I can take a look at what that is. Okay, so that many days ago, that was my balance. If I go back in time, my balance was, went in the wrong direction if I go back in time. Or actually, maybe not with this random data, it doesn't look like it. Anyways, that's just my fake data that I'm doing this. Okay, so what I have is there, but now I have an int and a double. But I can see that the query is, I'm running out of space. The entire query is running out. I can, of course, just, change how I view things in Visual Studio, but maybe a better way of doing it is, what if I created a view out of this data? As opposed to getting a longer and longer query, I'll just simplify what I'm doing, clean up the data one step at a time, and then just store the intermediate results as a balance. And so I'll run the exact same query that I had before. Oops, I'm showing too much. But then just run it as a view. Okay, yeah, so I'll run the exact same query as before, but now I'll store it as a view. The one thing is, hey, I'm creating this view. I'm not going to limit myself to the first 4 queries. I'm just going to run everything there. Okay, and so here what I have is I have a view, and I can do again the exact same thing as before. Just look at the first 4 rows. It's the same for first rows as I had before, but now I've simplified everything and condensed it to the balance. So here's kind of a little bit of the magic of DuckDB is I didn't start with a table of nicely organized data. I started with a bunch of CSVs, but I treated it as if it was a table. And now I have a view of this data that's stored in memory. So now I can query this data from memory and take a look at it. And okay, so now I have the inputs that I wanted. I have a integer and for the captures days ago, and I have a balance. And now I can do capture the slope, for example. What does the slope mean when I take the balance and days ago? It's the amount, how fast I'm repaying it. And so here, the function regSlope takes the first input is the y, how fast things are moving up and down, which is the balance, and the x-axis is the number of days. If I look, the way that I set up days ago is that it's an increasing number that goes backwards in time. So even though I would think, and that means that as I'm looking at this balance, it's actually giving me a negative number. So that's going down how fast it is. So I'm just going to multiply it by a negative number to just, so when I look at it here, I remember, okay, it's the, how that just undoes my weird change of a date variable to give me something positive. And if I look at those numbers, okay, so it's a large number of payments per day, but it reflects what happens over the entire history of my transaction. And I know at the beginning I was paying faster because I was moving around money as I got my loan set up. So what if I look at not the entire history of the data, but only the recent events? So here I'm going to say days ago, and I'm going to restrict that to say, well, how many days ago in the past? Like roughly the last 6 months. If I take a look, oh yeah, it's 45 days. And again, I could just create a nice view inside of that. So I'll store the payback rate as a single, as a number inside of a view that's called payback. And so what do I want that number for is, well, if I know how fast I'm paying back the amount and I know the current balance, I could just divide the two and that will give me the number of days left to pay back. And that's what I'm doing. I'm taking the current, just select the balance from balances where I'm looking at the last days. If I do that, okay, so now I have a view which contains a single number, which is the current balance. So if I want to know how many days I have left, I just divide the two. Okay, so I have 3,000 days left to pay back. If I want to get a date, well, I can take the current date plus the number of days that are there, which is, so I have to create an interval. The interval in terms of days is based on this, and I'll just do a select statement there. So again, so here's a kind of the niceties of DuckDB is I could do a from statement. I don't have to start with select something to do it. I can just start from some statement, and same way I can select a statement without having a from if I'm only using numbers. And the end result is, hey, in 2032, September the 19th, I'll have my loan will be paid off, or the principal will be paid off. Yeah, so that's a quickly how I use DuckDB, where I start off with a bunch of files, run some queries on top of it, just treat it as if it's a database, run everything in memory, and just close it. Then now I have, if I could just do this again, I have the demo.sql, pass that to DuckDB, look at the output, and that file number is there. And of course, then I can, when I was doing in my previous example, I have done a bunch of other cleanup functions. I've added the ability of, well, oh, that 1 account is the loan account, but I have a 2 account, which is the offset. Putting them together, and it gives me better numbers. Okay. Yeah, so here maybe I'll go on into, so this is kind of the end of this. Maybe I'll go here in the kind of the after dark and think about where did I mess up when I ran these queries, just to give you some hints of like, hey, I have CSVs, what else should I be thinking about is when I was re-looking at this query here, let me go back to DuckDB, looking at this format here, I'm looking at a date, but what date am I talking about, right? When I was doing afterwards, when I'm using current date minus date, am I really comparing oranges to oranges? And the question is that it's actually no, because I'm ignoring time zones. So the current date method actually gives me something in UTC 0, where I am in UTC plus 8 in perf. So there's a difference there. And here date is simply what the bank is. And I haven't looked at the documentation, but the bank doesn't tell me which time zone I'm interested in. Okay, that's problematic. But there is ways of fixing it where, hey, instead of using like a method like current date, which doesn't have a timestamp, I can use a method, very simple method, which is say select now. Take a look at that. Oh yeah, it's a timestamp with time zones. It gives me the current local time. And when I import the data, I can import it with a time zone of UTC plus 8. Okay, so now I'll be comparing, oranges with oranges in terms of time zones. Another one that is um, around the data is what am I actually, when I'm using my regression, I have again just a bunch of days inside of that. But can it happen that I have multiple transactions and on the same day? Yes, that's true. And then, well, should I use the multiple values in the same transaction? Does it make sense to do so? Yes or no? One way of cleaning it up is if I look at the transaction files, I don't know the timestamp of when any of those occurred, but they come in an order. So if I look at a file of transaction, the top row is the last transaction in the day. So here, when I wanted to kind of improve the transactions, instead of using all of those partial transactions that are on the same day, I could just do a statement that will go and select the first um, balance, and then da 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 da, and then I'll have an order by sorry, not an order by, but a group by date or days ago. So here I'm gonna only focus on grabbing the first row that's there. So that helps me just a little bit of cleaning up data. Another one that I'm doing here is if I look at the data again, let me just look at the last 4 rows. What do I notice is that I have a bunch of gaps inside of my data where I'm not looking at day per day per day. I don't have a transaction every single day. I only have a transactions every once in a while. And if I wanted to do linear regression on top of that, if I think of the numbers, it's going to give me one number here, one number here. And then I have a straight line. Instead of that, okay, that looks like a pretty good balance. But really, if I think of, even though I don't have a record for every single day, I know exactly what happened between the different days. Is because on May 21st, I have the exact same balance. May 2nd, the 22nd of May, I have again that same balance. May 23rd, I have the exact same balance. So if I want to give a more accurate linear regression, I should actually make sure that I do an interpolation inside of that. And it's not going to be an interpretation where it's a temperature reading where, hey, but if I know it's 25 at 10 a.m. and 30 at noon, well, between the days it goes up and up slowly over time. It's a step interpolation where on the 21st it's the same value as the previous value, and the second 22nd is the same value as the previous day. And then that will fill forward the data. So these are again kind of techniques that you'll have to do yourself on top of this data. It has some understanding of time series data, but not a full amount. Those are kind of the tricks that you use to kind of improve your data handling. Okay.